This unit is all about triangles. So we're going to start off with the properties of a triangle, and then we're going to move on to some trigonometry. Now you may think that trigonometry has been beaten to death. Why do we have to learn trigonometry every year? This version is different than you have learned before. We're going to learn some tools that you can use with non-right angled triangles. So different kind of trig skills than the SOHCAHTOA. But first, I want to introduce the triangle to you. So I know you probably haven't heard of one before because they're very rare and exotic beasts. And so let me show you what they're like. A triangle looks something like this. That's one kind of triangle. Here's another kind of triangle because there's actually many species. Here's another kind of triangle. Okay, so we've got the basics are triangles have three sides. It's a three-sided shape. So if we count the sides together, 1, 2, 3. See? Now, a couple other things that maybe aren't as Sesame Street about it. The sum of the three interior angles is always going to be 180 degrees. Now maybe you remember that from the past, but that means that this angle plus this angle plus this angle, they're going to add up to 180 degrees in every single triangle, no matter what kind of shape it is. So even though this top guy here is a 90-degree triangle, and this middle one over here is not a 90-degree triangle, it's an acute triangle, and this one over here is an obtuse triangle, all their angles will always add up to 180 degrees. Okay, that's an important thing to remember. And finally, a triangle is a closed figure. So this is not a triangle. That's not a shape. It's not a closed figure. It's three line segments put together. So it needs to actually be closed, but hopefully that's obvious. So we know the important things about a triangle now. Maybe you knew them before. And we're going to talk about how we classify triangles. Okay, so we've got two different ways of classifying triangles. The first way is by angle measure. Okay, and so let's look at this triangle over here to begin with. This is an acute triangle. An acute triangle has three angles that are all less than 90 degrees each. Okay, so if we look at each of these, this one I can tell is smaller than 90 degrees because a 90-degree angle looks like that. It looks like a square corner. This one is closer to 90 degrees, but it's still smaller than 90 degrees. And this one is also smaller than 90 degrees. So they're going to still add up to 180, but none of them is as big as 90 degrees. So the first one, classified by angles, is an acute triangle. The second one is a right triangle. And that's a lot of the triangles we've been working with in trigonometry up till grade 12 are all 90-degree triangles. You can tell they're 90 degrees because they usually have this little square in the corner, and that tells you this corner is exactly 90 degrees. So that's a right angle triangle. And then the obtuse triangle, the important thing about it is that one of the angles is bigger than 90 degrees. Okay, so if it were exactly 90 degrees, it would be like this. But this side right over here leans past that vertical line, and so it's greater than 90 degrees. The other two angles are going to be smaller than 90 degrees. You'll notice that usually they are very small looking, because if this obtuse angle over here is bigger than 90 degrees, the three can still only add up to 180 degrees, and so the remaining two can't be very big. We can also classify triangles by side length. So the first one was classifying triangles by the type of angles they have. The second part is classifying them by side length. So the first type of triangle is kind of your most classic triangle, three equal sides. That's called an equilateral triangle. And you can tell they're three equal sides because these little tick marks over here, each of the sides has a tick mark on it. And we use those little tick marks to denote that they're the same length. Okay, and so in that triangle, all three of them are the same length. That makes it equilateral. An important thing to also note is that in equilateral triangles, the angles are all equal too. That's kind of a byproduct of it. So let's think about this for a second. If the three angles have to add up to 180 degrees, what is each angle? If they're all equal to each other, that 180 degrees has to be equally split among those three angles. Say it out loud with me. All right, 60 degrees. So 180 degrees divided by 3 gives you 60 degrees each. So in an equilateral triangle, the angle measures are always 60 degrees each. The second type of triangle classified by side length is isosceles. Isosceles means it has two equal sides. So notice the tick marks over here and over here. That means that this is an isosceles triangle. What goes along with that is that these two angles down here are also equal to each other. And that makes this isosceles. The last one, scalene, that just means it doesn't fit any of those other two. All sides are of different lengths and all the angles are different measures. Okay, so you can get all sorts of different triangles that way. Like you could get some acute triangles or a right triangle or an obtuse triangle, but the main thing is that nothing matches. You don't get pairs of anything. So if we look at this right-angled triangle over here, I can tell that this angle and this angle are not the same. This top one is bigger. And this one's 90 degrees. So obviously that's not the same as the other two. And then if I look at the side lengths, this side and this side are not the same. The bottom side is longer, and the hypotenuse is going to be the longest of all, right? So nothing is the same there. None of the side lengths are equal to each other. None of the angles are equal to each other. And so we would call that a scalene triangle. So we can classify triangles by angle, acute, obtuse, or right, and we can classify them by side length, equilateral, isosceles, or scalene. So provide two names for a triangle that has two equal sides and whose angles are all less than 90 degrees. Okay, so first of all, two equal sides, that means isosceles. Or, as I like to say it, isosceles. Now I messed up my spelling. Here we go. Okay, an isosceles triangle. And when all the angles are less than 90 degrees, you can look above and check out what that means. But that's an acute triangle. So we would call this an acute isosceles triangle. Or acute isosceles. That's really wrong. Don't say that to anybody. B, what type of triangle has no equal sides and one angle greater than 90 degrees? No equal sides, that's scalene. And one angle greater than 90 degrees. Greater than 90 degrees, that's this type of angle. That's obtuse. Okay, and so we would call this an obtuse scalene triangle. Now, as far as I'm aware, there's not really a rule that you have to classify the angle before the side length classification. It just sounds better in my ear. But if you want to call this a scalene obtuse triangle, I'm not going to argue with you too vehemently, so feel free. Okay, now we're going to do a little bit of problem solving using the properties of triangles. We're supposed to classify triangle ABC by angle measure and by side length. Just going to grab a different color really quick. So by triangle ABC, it means we're connecting this corner and this corner and this corner. So the D over here, that's not involved in the triangle we're talking about. Okay, so we're connecting A, B, and C, and back to A. And that makes our triangle. And so by looking at this, I can see that we've got two side lengths that are the same, but the bottom is not the same. So that would make this an isosceles triangle, right? And I can see that the bottom is 62 degrees, and so that would also make this 62 degrees, right? Because in an isosceles triangle, the two bottom angles, not always bottom, but the two angles that are opposite the equal sides, those ones are the same as each other as well. So that's 62 degrees each. That means that this angle up here is less than 90 degrees. Feel free to add them up. So 62 and 62 is 124, and from 180, that leaves 56 degrees. Okay, and so this top one would be 56 degrees. That's a 6. Let's try this again. 56 degrees. There you go. And that makes this an acute triangle. So I would call it an acute isosceles triangle. Again, you could call it an isosceles acute triangle. That's fine. What is the side length of AB? Okay, so AB is this side length over here. We don't actually need to do any calculations to figure that out because we know that this side length is the same as this side length. And so that would be 17 centimeters then. Bonus, what's the length of CD? That's down here. For that, we would actually need to do a calculation. For that, we would need to do some sort of SOHCAHTOA work. Okay, so we know that this is 62 degrees down here, and that would make this the opposite side, and this the hypotenuse. This would be the adjacent. Okay, and so I know the opposite and I know the hypotenuse. I just need to figure out the adjacent side. There are a few different ways of doing that. I can use SOHCAHTOA to figure it out. Opposite over adjacent. I could use the Pythagorean theorem, a squared plus b squared equals c squared, to figure it out. I'm going to choose the SOHCAHTOA method. So I'm going to do the tan of 62 degrees. If you remember, tan is opposite divided by adjacent. The tan of 62 degrees is equal to my opposite side, which is 15 centimeters, divided by my adjacent side, which is my x side. And then I have to do some algebra. I have to do some rearranging of this thing. If you remember way back, our quick step, in class we're going to talk about the non-quick version of that, is those two things switch places. Okay, so we get x is equal to 15 centimeters divided by the tan of 62 degrees. And that is equal to about 8 centimeters. Bonus! Last example here, use the given angle measures to calculate the unknown angles in each triangle. We're supposed to include interior angles and exterior angles. Record the measurement on the diagram. Okay, so let's start with interior angles. 32, 105, what's this missing one? Okay, we said before that they should add up to 180, right? So if we go 180 minus 105 minus 32, that gives us the leftover for that missing angle over there. Okay, and that gives us 43 degrees. So that's this interior angle over here. That's 43. Okay, now the exterior angles, that's a different thing. We haven't really talked about that, but let me show you how it works. The exterior angle to this 105 would be this piece over here. Okay, notice the shape that this 105 and this missing piece makes. It's a half a circle, right? If we would keep going all the way around, you'd get a whole circle. Now, a whole circle is 360 degrees, so a half a circle is half of that, which is 180 degrees. Okay, and so what that means is that the 105 and this missing angle, I'm going to call it A. The 105 and A together need to make 180 degrees. And so if we go 180 minus 105, that will give us angle A. And so angle A is equal to 75 degrees. Okay, so we've got kind of two 180 rules here. The first 180 degree rule is that the three angles inside a triangle, the three interior angles, add up to 180 degrees. And the other 180 rule is that any two angles that add up to a straight line, like this one and the 43, or this 32 and this missing piece, those all equal 180 degrees as well. And so you can just subtract the one you know from 180 and get what's missing. Let's do number 2 over here. We're given this angle over here is 120 degrees, and we're also told that this side and this side are equal to each other. And so if we remember isosceles triangles, the two opposite angles from these equal sides are also equal to each other. So that means this angle and this angle are equal to each other. And so what we need to do is take this 120 degrees and subtract it from 180 to give us what's left over for those two missing angles that we're going for. And that's 60 degrees. So 60 degrees is what's left for those two angles, and they're the same as each other, which makes them each 30 degrees, right? So this one is 30 degrees, and this one is 30 degrees. Now I'm not going to do the exterior angles for this one as well, because it's the same thing we did on the first one. Just take your full 180 and subtract the piece that you know, and that will give you what's missing. Now the last one gives us a slightly different set of information, and so figuring out the interior angles will take one extra step. So I know that this top one over here is 20, and I know that the exterior angle over here is 55 degrees. And so I really want to know what this one is. So the way that exterior angles work is the full straight line, or the half circle, is 180 degrees. And I want to subtract the piece that I know, which is 55 degrees. And that gives me what's left over, 25 degrees. 125 degrees is what I meant. I can do this. And so this interior angle here is 125 degrees. I know that the top one is 20, and so then I can figure out this bottom one over here. Okay, so we do 180 minus 20 minus 125, and that leaves us with 35 degrees. And that's the last missing piece. Then you can do the external angles as well.